Significant figures, precision, and accuracy. Please note that significant figures are also going to be referred to as significant digits and sig figs. Precision and accuracy. Precision is the level of detail that an instrument can measure. Small units of measurement or fractions of a unit are always more precise. For example, millimeters are more precise than meters. And if you have a number with two similar units, for example, 6.173 liters and 6.2 liters, the one with more decimals is the more precise one. Keep in mind, when we say something is more precise, we are not saying that it is more accurate. It just means that the number or the measurement has a lot of detail. A lot of people confuse those. Just keep in mind, accuracy is how close something is to the actual value. Let's do an example. Jordan is testing the scales in a butcher shop. He uses a standard weight of 16 ounces. Standard weight just means that the weight should be 16 ounces when it's placed on the scale. The results are shown below. So if you look at the chart, we have 4 scales, A through D, and 4 measurements. Part A. Which scale is the most precise? Explain. Well, with precision, we're looking for smallest unit of measurement and the most decimal places. And the scale that fits that would be one that has ounces, and scale C has the most decimal places. Therefore, that is our answer. Part B. Oh, before that, if we were to change 1.1 pound to ounces, we would not get a measurement that's any more precise than C. All right, now part B. Which scale is the most accurate? Explain. We're looking for the measurement that's closest to 16 ounces. It's definitely not D, because 17.6 ounces is too far away from 16. And A, B, and C are all fairly close. However, scale B is only 1/10 of an ounce away from the actual amount. Scale C is 13/100ths of an ounce away from the standard weight that was measured. Therefore, the answer is scale B. Significant figures in measurement. Significant figures contribute to the precision of a measurement. They are the digits that carry meaning. Sometimes they're also called significant digits, or you might even hear somebody say sig figs. At this point, you're probably wondering, how do you determine the number of significant figures in a number? It's fairly easy, and we're going to cover 3 simple rules to help you count the significant digits. Rule number 1. Non-zero numerals always count as significant figures. Non-zero numerals are numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9. So let's do some examples. We're only going to look at the number of non-zero digits. So first, the number 374. Well, all 3 of those are non-zero. Therefore, that's how many non-zero digits we have. 5.6 light years. We have 2 non-zero digits. The next measurement has 5 non-zero digits. And the last distance, 2.398, has 4 non-zero digits. Rule number 2. Captive zeros, also known as sandwich zeros, are those that are between non-zero digits and always count as significant figures. Let's look at the first measurement, 50.8 degrees. The zero in between is a captive zero. And in our table, we're going to count how many captive zeros we have. We just have 1 there. 2001 minutes. Notice those zeros are in between. Think of that zero in between the non-zero digits. There are two. Next number is a little bit trickier because we have zeros at the beginning and we have a zero here. Always go back to the definition. We're counting zeros between non-zero digits. The only one that fits that bill is the 0 between the 4 and the 5, so there is only one captive zeros. Don't worry about the zeros in the front. And the last number has 2 captive zeros. Rule number 3. Trailing zeros, those at the end of a number, are significant only if you see a decimal point. You either count all the trailing zeros or none. The reason is that the decimal zeros make the number more precise. Let's count the significant trailing zeros. In the first measurement, 9.30 inches. We do have a trailing zero and we have a decimal place. Therefore, we count it. 8,000 people. We do have zeros at the end, but there is no decimal place. As a result, we can't count those zeros as being significant. Keep in mind, if a problem ever states that all the zeros are significant, you would count them as such, but if you're not told any detail, then you can't go by that. 400 point seconds. When a number is written this way, it's telling you that the zeros are significant. And finally, 17.000 amps. That's more precise than just 17 amps because you know that it's been measured to 3 decimal places. Those zeros are significant. Here's a summary for measurements. Rules 1, 2, and 3. One more thing to note is that exact numbers have infinite significant figures because they are as precise as they can be. This includes counted quantities. For example, if you count that there are 16 people in a row, you can't get more precise than that. In addition, defined numbers. 1 minute equals 60 seconds. If you're converting 1 minute to 60 seconds, then that number 60 seconds is infinitely precise. Let's do some examples. We're going to write the number of significant digits according to each rule. Then add them up to find the total number of significant digits. All right, if you look at the first number, we have 64.10. I'm going to break this down, and what I like to do is I check off each number as it satisfies the rule. So first I'm going to count the number of 0 numerals, numbers 1 through 9. Well, I have the 6, the 4, and the 1. I have 3 non-zero numerals. I don't see any captive zeros, and this 0 is trailing, and I have a decimal point there, so therefore it is significant. I check it off and add up the total. 3 plus 1 is 4, so we have 4 total significant figures here. If you were to write this number in scientific notation, that number would also show you that you have 4 sig figs. Okay, next number. 5,807 liters. All right, first we count off the 5, the 8, and the 7. That 0 is between 8 and 7, therefore it is a captive zero. I don't have any trailing zeros, so therefore this 3 plus the 1 gives me 4 significant figures. And here's that number in scientific notation. As you notice, you have 4 numbers underlined here, and that's how many significant figures there are. Finally, 0.00077 coulombs. All right, we check off the 2 7s. That's the easy part. Captive zeros. These zeros aren't captive. They're free to go to the left, so we can't count those, and there are no trailing zeros. Therefore, we have 2 total significant figures, and here's the number in scientific notation. Here's some examples for you to try. I recommend you write down each number and check off above each significant figure, similarly to what we just did in the previous example. At the end, the main thing that matters is that you have the total number of significant figures. Pause the video here because the answers will appear soon. Here are the solutions. The underlined digits are those that are significant. It'll match up with this number here. 3 dogs down here has infinite significant figures because it is a counted amount. Thank you for watching the video, and if you would like to practice with the online quiz, click on the link below.